Hello everyone, I'm Xiao Gang. Let's take a look at a slightly more complex example of a timer event. I'll say a bit more here. Actually, I've used timers before, and I often just read a superordinate term under the target with the timer to save trouble. When we do lib detection or some delay design, we might need to read the camera values under the target for a few seconds or 10 seconds, and sometimes we use the camera. And there are some operations you shouldn't do, like what we mentioned before, database networks, or some large file I/O. And another thing is, don't do any image compositing inside the timer. And reading, writing, and outputting audio streams. These all need to be done in multi-threading. Okay, let's briefly look at the example. The effect of the example is pretty good. He made a timer, then finally executes this go and explodes, and it's written in C++. Actually, after it explodes, you can trigger your game mode and let each player regain control of their character. Then you can start a game. That's roughly how it's done. Let's see how many steps he divided it into. First, still create our accolade. Nothing much to say. Then here, a few variables are given. Obviously, there is a countdown time. Then there is a function to trigger the display update each time. And then there is a rounder, that is using the text rounder component. Obviously, this is a scene rendering component. Then after declaring, here in the original file, we remember to include its header file. Then in the constructor, we initialize some diameters. This place is very good. It turns off this tick because it doesn't need to tick anymore, because even the timing is done using a timer. It just doesn't really need to tick anymore. And here it was initialized, this component, that is when a text rendering component, and then the alignment of the text rendering component was set, as well as a size. Finally, this text component was used as a root node, and then it renders into it. We emphasize the root node again, then set this timer duration. As for this function, it essentially reads our current countdown time, then it performs a math operation on it. Our math operation does this. It ensures the time cannot be negative because the countdown reaches 0. So it takes the maximum of the two values, the time and 0. Then this f is finally converted from an integer. This is a very common operation. Sometimes we need to deal with conversions between floating point numbers and strings. It seems we haven't covered this part yet, but there are some hidden pitfalls here. Then set it to txt here. Then just turn the key and you're in. Then at this moment, at this point, there is a countdown ending here this time, and then there is an advanced timer. Let's take a look inside the advanced timer. It actually should be the bound function. Yeah, the bound function. This is triggered continuously by the timer, so actually this is its function. Obviously, hey, it follows the writing style from our lesson, which is you check first, then make the judgment. Otherwise, if you write it all together, sometimes it doesn't look good. And it's not easy to read. Actually, having one more or one less line of code often doesn't make a difference, because this is not a hotspot issue. In performance analysis, it's often 20% of the code. That takes up 80% of the performance. You only need to optimize that 20% of the code. As for some minor details, it's best to write them for readability. Actually, we all know that macros are very convenient, but we strongly recommend not using macros in your actual development unless you are writing low-level code, or you need to train your memory. Then you can use more red to enhance your core memory. Most of the time, please do not use red. Then in this place, when we display and update the displayed text, when it is less than 1, then we consider the timer to be complete. That is, it is already 0. Actually, then we first clear the timer, then complete the last text display. Then when displaying the text, it takes the originally displayed this text and change it to the text go. You can see that it actually should have no 0. Let's watch it again. 3, 2, 1, go. It actually has no 0, right? Because at this point, 0 is already enough. Okay, finally, it is in this. The function is at the begin play location. Don't put it in the constructor. In the last class, we demonstrated to you putting it in the constructor. You will find that it simply won't start because it is inside the constructor function. It cannot correctly obtain the timer manager. Then at the very beginning of begin play, we first updated a 3, then trigger this timer. There is no problem with this part. So This is one of its input parameters. Okay, actually here we can, this part is haltbar, but sometimes we can make a generic timer. We can expose the time we want to set. We can expose the text we want to display. We can expose the operation we want to execute. Actually, users or our front-end planners and artists, they don't care about. He just needs to know what values I need to pass in at different places. Then it can trigger certain events. So this is clearly an encapsulation. And here, he has set up a scene layout. This is one of his semi-finished code pieces. Now he starts to make it public. First, he exposes this time variable. Then you can, from anywhere, on the Blueprint's default interface or on the Blueprint's details interface. This details interface is for instances. We can configure it on the instance, or we can uniformly configure a time value. That's right. Also, you can add some comments. That's perfectly fine too. Then, in this place, this function, when we finally finish executing, we can use a special method to expose it to the blueprint so that the blueprint can implement the corresponding logic. Then in this place, we set it to uShift. And in this place, it can have a native C++ implementation as well as a blueprint implementation. So let's first define a native implementation. Okay, so this is how we write the code. And then in the blueprint, we override this. It's blueprint implementation. Then we can make it play the particle. Then you'll find that after doing this, it does not trigger the native C++ world. If you want it to trigger, then you just need to call its parent, which is what we often call super in C++. And that's it. Another example is generated here. This example is the particle example included in the beginner's pack. Then the result can achieve this effect. It's quite simple. Then you can create many interesting designs. For example, you can make some like up and down movement or double dot designs. You can also change the execution effects of these examples or trigger them periodically. Maybe you need this scene to set up this example. Maybe every 10 seconds, a spark will be emitted in this scene, or a bolt of lightning will be released. You can use this timer to do it. None of these are a problem. Okay, then in the next lesson, we will implement this simple example. Okay,